Hello guys, so we are going to discuss about the dimensions of the pipe, and we are going to have a very important discussion over here. And many a times people get confused with what is the pipe dimension actually. So whenever you are ordering a pipe or you are seeing the pipe name or number, if it is written like, say, it is written 20A, okay, or 30A, what do you mean by this? So
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
actually, when you see this is the sheet for the carbon steel pipe standard. This is called pipe standard. Okay, so both the sheets are for the carbon steel pipe standards, and the next is for the stainless steel pipe standards. Similar funda, only the stainless steel is more stronger pipe having higher tensile strength, and the carbon steel is a lesser one. So mild steel pipe, these are mild steel pipes. So what is actually the first one, you can see it is the nominal dia, and now many people get confused with nominal dia being the inner dia. So no, in the pipe standard there is no role of inner diameter. What we address the pipe as the nominal dia. So when you see a 20A written somewhere in the pipe or in the valve, like it somewhere in the valve it is written DN40, that means the nominal dia is 40 mm, or say inches. In inches, if you take 3 by 8 inches, so a column here is for the column, and B column similarly is for the inches. They are more or less same. 3 by 8 inches will come more or less equal to 10 okay, but not equal. So different makers use different type of nominal diameter. Maybe they will use for inches or they will use for but why do you use a nominal dia? If you are going to measure anywhere in the pipe, you are not going to find any nominal dia. So nominal dia does not exist in reality. It is a theoretical data. And why do you use a nominal dia? Because your outside thickness can be something like this, 17.3. You can see this is the outer dia for the same pipe. 10 nominal dia, outer dia is 17.3. Okay, and thickness for the same pipe is 2.35 okay. So the outer dia or inner dia can be variable according to the thickness size. Okay, outer dia will be constant for one pipe, but inner dia will be variable according to the thickness size. So you don't take inner dia anywhere. What you take is nominal dia. Nominal dia is just like a pipe address. When you are ordering a pipe, you order a pipe with the same nominal dia. The thickness can vary. All you have to write is a nominal dia and the outer dia of the pipe. So as per the pipe standard, because you can see, as last one we had seen in the last video, SPP is one type of pipe. Schedule 40 schedule, we will see what it is. SPP is one pipe. PG is one pipe. ERSW, these are all the pipe material type, how they are constructed, on what materials, on what welding type they are done, like electric resistance welding, or say seamless pipe, or arc welding. Okay, STPY is arc welding. So in what kind of construction or what kind of material it is being used, that is the pipe material. So on the basis of that, the pipe sizes will vary according to the tensile strength, but what remains constant is the nominal dia for the pipe. If it is a stainless steel pipe or it is a um, mild steel pipe, the nominal dia remains the same. So it is, you will not be able to locate this. So this, if this is a pipe, say this is the OD, this is the OD, and this is the thickness. Okay, this is the thickness. So if this is the OD, outer dia, you will not be able to find the nominal dia. Chalo, let us take an example. Say this is the 10 nominal dia pipe. 10 nominal dia pipe. The outer diameter has been given as 17.3. Outer dia is 17.3 OD. The thickness is 2.35, so 2.35 multiplied by 2 will be 4.70. So if you reduce this from the OD, 17.3 minus 4.70, it will come to be 12.6. We is it so inner dia is 12.6, outer dia is 17.3. Where does 10 exist? So it does not exist anywhere. It is just for the manufacturer to know what the pipe size has been ordered as, what is the nominal dia. So nominal dia is a theoretical number for name of the pipe, you can call it, okay, of the pipe size. So similarly nominal dias like 15, so this is in mm, this chart all goes into mm. This is what I wanted to discuss. You can see there can be numerous number of nominal dias, but to keep it as a standard value either in inches, it is not coming in decimals or something like that, it will be a standard value. That is why they have kept it as a numeric uh, whole number, okay, 100, 125, 150, this will be the number of the pipe, okay, pipe number, that is the nominal dia, okay. Through with that you will order the pipe, okay, and depending on the OD and nominal dia and the type of pipe you have measured, sent that like um, SPP pipe you want, or STPY pipe you want, or ERSW pipe you want, they will make manufacture the pipe according your schedule 40 pipe you are going to order, okay. Now coming to you can see in this section it goes up to 1000 mm, nominal dia goes up to 1000 mm, but we use pipes, say. Now what comes is the outer diameter varies accordingly. So if the nominal dia is 10, outer diameter is 17.3. If nominal dia is 15, outer dia increase. So as the nominal dia increases, the outer diameter also goes to increase, okay, 20, 27.2, 25, 34. So as the nominal dia increases, the thickness increases here. You can see 2.35, 2.65, 2.65. So thickness can also be same, and you can see the mass, the weight here, kg per meter, how much kg per meter is the weight. So per meter what is the weight? 0.87 kg, 1.25 kg, 1.60 kg, okay. Even if this pipe is smaller, the thickness of both the pipes are same, okay. So through outer diameter and the nominal diameter they will come to know as to what pipe thickness they will require, okay. So this is about the SPP pipe. Let me show it to you. So since we have read in the last section, SPP pipe is meant. So in the bottom you see material. SPP is circled here. So in until this number, until 600 mm, you can use a SPP pipe. After that, what happens? The material needs more strength, so you cannot use this general service kind of pipe, SPP pipe. So for that you are using STPY 400, which has got 400 uh, megapascals of tensile strength, because the pipe nominal dia is increasing. You can see after the thickness is 7.9 mm thickness, then your nominal dia is above 650, then you will use different material, STPY 400, okay, 129, 137, these are the weight. You can see the weight per meter, 130 kg per meter, 140 kg per meter, 147 kg per meter. So this is the weight depending on the material. Now next is the concept of schedule 40. Schedule 40, what do we mean by schedule? And this is a very common term in the pipeline industry. What is a schedule? Pipe schedule, we call it pipe schedule, okay, SCH40. So there was a scientist named Barlow. So there is a modified wall thickness formula, modified wall thickness formula. devised by Barlow. So basically what it is, schedule, we are talking about the wall thickness here. How do you determine the schedule? There is a formula for schedule number. SCH number, schedule number is equal to or equivalent to 1000 multiplied by design pressure or the service pressure divided by the allowable stress, the tensile stress that we are talking about. So all the pipes are working on the basis of this tensile stress. So these are all in say megapascal, design pressure, allowable stress. This is in megapascals, tensile stress. So they will, units will cut out and this number will come out to be a dimensionless number. Okay. Okay, so schedule 40, as we can see, for a pipe type the allowable stress is fixed, right? As we know that for say SPP pipe there is some fixed allowable stress. For STPY pipe, say there is a allowable stress of 400 uh, megapascal as the tensile stress. It has been tested for that material type. So a material type can have a fixed allowable stress on a given time. So what can be changed? We can change the design pressure. So in the formula, if you are going to change the design pressure, what will change? If you are going to change the design pressure, so if you want to use a more say the schedule number should be higher, what does it indicate? That means the higher schedule number pipe is used for higher pressure service. Okay, say if you are increasing the pressure, so you will use more higher schedule number. So basically the thickness will also increase and the schedule number will increase. In the terminology, if you are using schedule at 80 pipe, that is a more thicker pipe and it has got a larger diameter and it has been used for, it is to be used for higher pressure. So basically we are talking about the wall thickness. So by increasing the wall thickness, we are thereby increasing the schedule number. And how we are increasing the schedule number? Why we are increasing the schedule number? We are increasing the schedule number to use it for a higher service pressure. Okay, if you are using schedule 40 for 20 bar pressure, then you will use schedule 80 for say 40 bar pressure. Just for giving example, so if you want to increase the service pressure, you have to increase the schedule number. So that is what a schedule number is. Okay, now you can see the thickness for schedule number is almost same for as the SPP pipe, but the pipe material you can see is changed. The pipe material for the schedule 40 is STPG 370. Okay, so the since the material is different, the pipe strength will be different. When we are talking schedule, we are talking the wall thickness. So this part is about the wall thickness. So you can see above this 7.9 mm, this is standard 7.9 mm will be the thickness. Above that the thickness will not go for this version, for the pipes STPY pipe 7.9 mm in the carbon steel standard. In this one, for schedule 40 pipe, for schedule 40 pipe in different material grades, for ERSW grade, so ERSW grade you can go up to 9.5 mm of thickness. Okay, and you can go up to 600 mm of nominal diameter. Okay, so nominal diameter can go up to 600 mm and 9.5 mm thickness. Above 9.5 mm there is no thickness, only the weight increases. Above 9.5 mm, as the nominal dia increases, the weight increases. The weight is increased to compensate for the bigger diameter, but the thickness is not increased further. Okay, so you can see 9.5 is the maximum thickness for the schedule 40 pipe. Okay, 9.5 up to 1000 mm and 236 kg per meter is the weight. The pipe type is material is STPY 400. Okay, So STPY 400, because 400 is the tensile strength, 400 megapascal. So it is the maximum tensile strength. You can see the bigger pipes above 650 mm nominal dia pipes, either SPP pipes or schedule 40 pipes. Both are being used to material. Both material is STPY 400. Okay, and in between either SPP pipe is used or your schedule 40 pipe is used here, STPG material 370 or ERSW 370, electrical resistance welding 370 is the pipe, that is depending on the strength. So that is the concept about the schedule number. Let us see the other chart for this. Okay, here what is happening. So schedule for until schedule 40 we have got a certain amount of pressure rating until which the pipe will work. Now we can see here it is schedule 80. So there must be a difference between schedule 40 and schedule 80. Now let us see. Chalo, for 10 mm pipe, for 10 mm nominal dia pipe, you can see the thickness is 2.3 when it is a schedule 40 pipe. When it is a schedule 80 pipe, the thickness is 3.2 and the weight is also increasing. Okay, so what does this signify? This signifies that we have increased the pressure for the same pipe, and outer dia is constant. You can see outer dia is constant. If thickness increases, what reduces? The inner diameter. So this time the inner diameter, earlier for this pipe the inner diameter was what? Around 2.6, 12.6 inner dia. Here it will be lesser than that. So you understand. So as the thickness increases, outer dia remains constant, nominal dia remains constant. What reduces is the inner diameter. So the pipe is now lesser inner diameter. So inner diameter is always variable in the pipe industry. What is constant is the nominal diameter and the outer diameter. According to the schedule, according to the pipe material, the thickness will vary and the inner diameter will vary and the weight will vary. Okay, so what we have to see, we have to see what kind of uh, say schedule the pipe is, schedule or type, pipe type. You can see this one SPP or S schedule 40 or schedule 80, and these three things we will have to see when we are ordering the pipe: nominal diameter, outer diameter, and the schedule. So from that we can order the pipe. Okay, say 10 mm pipe, 3 by 8 inches pipe, outer dia 17.3, thickness 3.2, and weight is 1.1 kg per meter. So similarly this chart will also go up to various values. So you can see this chart ends up at 200. At 200 mm the schedule 80 pipe is changed. Now the thickness becomes constant at 12.7. Okay, so you cannot increase the thickness more than 12.7 for schedule 80 pipes. It goes up to 1000 mm, only the weight varies but the thickness, wall thickness remains constant. Okay, and the material varies. So first table is for STPG 370, second one is for ERWS 370. Both have same tensile strength, only thing is the type of material, I mean the construction type or the material type is variable here. Okay, last one is 400 tensile strength, STPY 400 tensile strength. Okay, next one is schedule 160. So you can see schedule 160 10 mm nominal diameter pipe does not even exist for this, because the inner diameter will be so less that it cannot even function well. So they don't give schedule 160 pipe for the 10 mm diameter. For increased 15 mm nominal dia you have schedule 160 pipe, thickness is 4.7 and the weight is also increased to 1.97. So it is the inner diameter reduces considerably in this case. So outer diameter is same 21.7 and the nominal diameter is same. Only thing is variable is the thickness and the weight for schedule 160. For schedule 160 it exists only up to say 125 mm pipe, 125 mm. After that the thickness becomes constant, up constant 15.9 mm thickness, 16 mm is the maximum thickness which can go for the schedule 160 pipe, and the weight varies accordingly as the nominal dia increases. As the nominal dia increases, you cannot order more than 600 pipe for schedule 160 pipe. For your information, most of the pipes in the engine room either schedule 40 or schedule 80 or the SPP pipes. Maximum you will find schedule 80 pipes, schedule 40, schedule 80 pipes, or the SPP pipes, general service pipes. Okay, so schedule 40, schedule 80 are generally used in the seawater lines where you need more thick pipe and the pressure is also more, flow rate is more. So there you are using schedule 40, schedule 80 pipe, big diameter pipes. But general service you will have SPP pipes or the stainless steel pipe if it is a very high pressure line. Okay, in the next module we are going to study about the stainless steel pipe standard. Okay, it is similar to the carbon steel, but at least we will see what is extra mentioned there in the stainless steel pipe standard. Okay, thank you guys.